Hand over today to Mark and Keiron and presenting on the TPMD stroke Southern Water Tunnel project. This actually won the land-based project award this year for the Innovation Awards in the Pipeline Industries Guild. Recording is being, the video is being recorded and will be put on the Pipeline Industries Guild YouTube channel afterwards. Along with, I think we've got about 30, 40 other presentations on there at the moment, so well worth a look on YouTube for Pipeline Industries Guild. Over to you, Mark and Keiron.
Thank you very much. My name's Mark Newman. I'm the project manager from Southern Water for the Thanet project.
My name's Keiron Lonergan. I'm the construction manager for TPMD.
So a little bit of background about Thanet itself. The Isle of Thanet is the most easterly point in Kent. It's made up primarily of the towns of Margate, Broadstairs and Ramsgate. And about 200, 250, 300 years ago, it used to be an island with a 600-metre wide Wonsum channel separating it from the mainland. Next slide. So this project came around primarily from an agreement between Southern Water and the Environment Agency made back in AMP3, and this is a partnership with the EA in their wider groundwater protection programme. So it was agreed it would be a 3 AMP project. So the first AMP, or first phase of the project from AMP5 would address all of the adits and network within the source protection zone, as there's a quite significant aquifer underneath the Thanet region. The AMP6 work, which this presentation is primarily about, would cover work within Ramsgate and Broadstairs, and there's a further AMP7 project which we're just starting to work on, which covers the network in Margate. The regulatory target date for this phase 2 work was the 31st of March 2020. Next slide. Thanet sewers are laid in deep exposed chalk tunnels, and these were constructed over 100 years ago by local miners when the mines in the area shut. And each of these tunnels is basically the size and shape of the person who dug them. So some are short and fat ones, some are tall, skinny ones. The main aim of this scheme is to restore the integrity of the sewer network and prevent discharges and remove any risk of future prosecution from the Environment Agency under the Water Framework and Groundwater Directives. So as I said, this is a 3-phase project. So phase 1 completed in AMP5 is the green area, roughly valued at about 30 million. Phase 2, the blue area, Ramsgate and Broadstairs, value about 35, and we think phase 3 in Margate will be roughly the same cost.
Okay, so Thanet has got a particularly unique sewer network that dates back over 100 years. The chalk tunnels, or adits as they're known to us, are in varying condition from being structurally sound to being in danger of collapsing. Miners excavated an extensive network of deep tunnels through the chalk to maintain the predominantly gravity sewer network. And as Mark mentioned earlier, these adits vary in size and shape depending on the miners that excavated them. You can see here from the photo on the right, this particular adit is quite tall and slim. However, some are short and wide, and this merely depended on the different groups or gangs of miners that worked in the tunnels. The combined sewer pipes were simply laid on the floor of the adits and were left open to the elements of the manhole locations. These adits continue to act as conduits for the sewer network, some of which are up to 28 meters deep. Next slide. There are 2 principal causes of discharge into these adits. Firstly, there is physical damage to the sewers within the adits, as you can see from the picture here on the right. This is an example of where the pipes are broken and lateral connections onto the sewer are defective. This allows sewage to escape into the adits and to come into direct contact with the chalk. Secondly, there can be shortcomings in the original design. The entrances to many adits are open at the manholes, allowing backflows of sewage to enter the chalk tunnels under surcharge conditions. There is also the fact that many of the pipe diameters were not suited to the increased population that we are dealing with today. The sewers are simply not large enough to cope with the demand. The population is greater, there are more houses, businesses, more schools, and all of this leads to an increased pressure on the network. Next slide. Surcharge conditions can arise as a result of design capacity of the network being exceeded through aforementioned issues, or as a result of storm events. There is also the issue of blockages within the sewer network. In conventional sewer systems, the surcharges and blockages result in above ground flooding, which would be quickly identified and resolved, whereas in Thanet, surcharge events often go unknown as the chalk adit contains these events. Next slide.
Sorry, I'm talking and I'm on mute. When we started phase 2 of this project, it was right at the beginning of AMP6, and our internal engineering and technical solutions team were engaged to put together kind of like, or to build a model of the network in the area, validate the model, and carry out some further survey work. Next slide. So initially, we carried out approximately 100 kilometres of CCTV survey on the existing sewer network. Through this, we identified all grade 4 and 5 defects in the sewers that we needed to rehab. We confirmed our existing network records and their accuracy, and this started the development of the hydraulic model. After that, we surveyed approximately 2,300 manholes with a 360-degree panoramic camera. The average manhole depth in this area is around 5 to 10 meters, but some of them go down to 28-30 meters in depth. And these surveys confirm the presence of open and closed headings within the manholes. Again, this further informed the development of the hydraulic model. We also installed some flow monitoring equipment as well, which further validated the model. Next slide. So from this survey work, we had an outline design which we took to tender. Eventually, following the tender process and value engineering workshops, etc., the contract was awarded in June 2018. So Southern Water engaged TPMD, who are a joint venture between Terra Solutions, Pfeiffer and Matt Durbin Associates, as our primary contractor. Mainly chosen because they were confined space experts. And we also engaged the WRC Water Research Centre to carry out kind of a quality assurance piece for Southern Water to aid us in getting sign off for the scheme with the Environment Agency at the end. Next slide.
Okay, so following on from the contract award in June 18, first task was to conduct walkthrough surveys of the adit. Most of the previous survey work carried out on the network was unable to ascertain the structural condition of the chalk adits, and for that reason we needed to conduct these walkthrough surveys. Once the surveys were carried out, the information could be fed back into the hydraulic model by working closely and collaboratively with the Southern Water hydraulic modelling team. Together, we could then re-evaluate the network hydraulically, whilst also considering the time and cost of repairing some of these defects. By having such a close working relationship between the client and contractor, there was an integrated approach to design, which also led to risks being identified at an early stage and being mitigated through design before the actual construction works began. Next slide. There were many challenges to these adit walkthrough surveys. Firstly, the identification of the network. The majority of manholes entered had adits leading in all 4 directions, and thus simply identifying where the sewer network was present and the direction of flow could be a challenge. Next slide. As previously mentioned, the depth of the network in places is up to 28 meters deep, and therefore even accessing the network is a complex, high-risk, confined space entry. Due to these tunnels being constructed many years ago, do not follow the rules and regulations we have in place today. Thus, some of the manholes on the same sewer line could be up to 200 meters apart in places, again making access and egress extremely difficult. Next slide. Many of the adits that we were looking at had blockages or collapses within them, making it unsafe to enter. In some cases, there were adits that were very structurally unsafe and needed emergency works carried out to ensure that a collapse beneath the road surface did not occur. This is a typical photo shown in the middle of the screen here. Where some of these collapses had occurred and chalk material had fallen from the roof of the adit, when looking up, a void had appeared, which sometimes exposed the underside of the road surface up to 5 meters above. These emergency work areas were highlighted to the client and to the hydraulic modelling team immediately, and therefore we could collaboratively make a decision on the required works and get them implemented before further damage could take place. We developed a system for filling these voids without the need to excavate the road above, which meant the issue could be resolved from inside the adit, which led to a more efficient and safer solution. The photo on the left, as I mentioned, shows a typical example of an adit that we were unable to walk through, whilst the photo on the right shows us removing debris from an adit that is structurally sound and didn't need any temporary support. We're now going to show you a short video of a typical adit that has been cleared of debris and is ready for the installation of CIPP liner. In these given times, please bear with us here because the technology may not show you the video in all its glory, and depending on the speed of the video, how it plays at your end, it may seem that my dialogue is a bit disjointed. You can see straight away the full nature of the adit and undulating sidewalls and varying roof structure. This adit is structurally sound and didn't require any support. However, it is clear to see that the miners are working free-handed and were not following a set line or level. You can see a band of flint material in the side walls, and this is a common vein found across all of Ramsgate and Broadstairs. You can see the adit widens and narrows along its course, and the height also varies slightly. Every 20 meters or so, you can see a widening here, which is a small man-made shaft, which is used to store materials or for passing within the tunnel. These sidewalls are often used to house lateral connections as well. The main point of the man entry surveys was that it was a cyclic process that enabled constant evaluation of the model and thus in turn the scope of works. As a result of the sensitivity of the model, the scope of works was changed accordingly, and the team could therefore proactively plan and coordinate the works with Kent County Council to ensure that we obtained the required road permits and space to carry out these works. We also worked closely with the Environment Agency to bring them along the journey with us to ensure they all understood the works that were being carried out. Next slide.
So once the survey work had been completed, we had our rough scope that we were going to be delivering. You can see the quantities on screen, but just the really important ones, we're looking at 7 kilometres of adit lining and adit prep, and we're looking at putting 2 kilometres of new sewer in the ground, as well as working on roughly 300 manholes. Next slide. So although this isn't completely clear, this is a high level view of Ramsgate. Every coloured line you can see on the drawing we were going to be working in. So the scope of works that was on the previous slide, every coloured line and dot on this line apply moving forward. And the next slide, if we go to that, Keiron. This is just one of those maps zoomed in much closer. So as you can see, the red lines were adits we were going to be lining. Blue ones were adits we were just sealing. Green dots replaced manholes, red dots new manholes, etc. So it was going to be quite a intensive amount of work to be doing in a small area within an 18-month time period. Next slide.
Okay, as previously mentioned, TPMD started the emergency works on the back of the walkthrough surveys in October 2018. And once these emergency works were complete, we could begin construction works, knowing that the entire area we were working in was free from any significant structural instabilities. The main construction works then started in December 18 and were completed by May this year, 2020. Slide. This is a typical sequence of work from start to finish of the work, and it started with the refurbishing and replacing of existing manholes. The manholes were constructed using a number of different techniques depending on surrounding logistics. The photo on the left shows a traditional sheeted pit with whaling frames. This could be used where there was no interfering existing services and there was adequate room for heavy plant and equipment. The more the manhole works progress through the brownfield site, the more we're encountering existing services and less opportunities we had to construct manholes in this manner. We then moved to the Keiron technique, which has a much smaller footprint and requires less heavy plant and machinery. This also makes the amount of traffic and pedestrian management more manageable and efficient on site. The next stage was to rehabilitate the existing sewers. The existing network is formed in two different ways. The first photos on the left show what we call an in-channel sewer. This is essentially formed from a concrete V-shaped channel, which is good when the flows are not surcharging. However, when they rise above the level of the concrete, the flows come into contact with chalk, and that is what we're trying to prevent. The photo on the right shows a traditional sewer pipe placed at the bottom of an adit. Much of the rehabilitation of this type of sewer is where a blockage or breakage of a pipe has occurred and needs to be replaced with a new section of pipe or to be relined or patched. The next stage of work is to remove the debris in place and make the adit safe to work in. It's clear to see from the photo on the left there's an unsafe adit which has suffered collapse and looks prone to further collapse. For this reason, at over 10 meters deep, this adit needed to be repaired using a traditional timber heading technique. Using this technique ensures that the miners are safe whilst working in the adit, but also enables us to remove debris and enlarge the adit to gain the greatest possible hydraulic capacity for the CIPP liners. You can see from this photo on the left that the aperture is approximately 500 millimeters high by 400 millimeters wide, which is simply not large enough to work in safely. Whilst making it safe, we can then liaise with the hydraulic modelling team to design the optimum size for the liner and work within that slide. The next stage is the relocation of all the existing lateral connections. You can see from the picture in the middle that the majority of the lateral connections come straight down from the soffit of the adit at the 12 o'clock position. This position not only prevents access, stops debris from being removed, but also blocks the CIPP liner from being installed. For this reason, we need to relocate the laterals by cutting them at the soffit of the adit and installing a series of slow bends to reposition them into the sidewalls of the adit so they do not project into the adit, thus reducing the available lining. This can be seen on the right-hand side in practice and on the standard detail shown in the photo in the middle. Next slide. The penultimate stage is to install a protective concrete foundation that serves two purposes. Firstly, to protect the freshly rehabilitated sewer beneath, and secondly, to have a smooth and solid base for the newly installed CIPP liner. Firstly, lay an impermeable membrane over the sewer and up 200 millimeters of each of the sidewalls before installing a 200 mm thick layer of C20 semi-dry concrete, which is delivered from the road surface through a flexible chute into the manhole base and transported down the adit line, purpose-built skip and rail system. The final stage is to install the CIPP liner into the prepared adit. Each adit liner is individually designed for the adit and is bespokely measured to ensure that it utilises the full capacity of the adit. The liner is drawn into the adit using a conveyor belt and folding machine, which can be seen in the photos on the right. This ensures that any risk is removed twisting the liner. Next slide. Firstly, we're heavily involved with the adit liner installation and witnessed every adit liner being installed in the ground. The bespoke design from manufacturer Reline Europe dictated the exact speed and temperature of the curing process to ensure the optimum cured solution for each liner. All of the installations were carried out successfully and were monitored from the new adit liner RE4000 vehicle with onboard analytical instrumentation. Next slide. The completed solution can be seen below, with the first full contact adit liners installed in the UK, shown in the two photos on the left. The adit liners came out extremely well, and this can be seen from these photos, making the most of the hydraulic capacity of the adit. The photos on the right show slightly smaller liners with oval and circular shapes being installed, where the optimum full contact liner was not required by the hydraulic model. Where smaller adit liners are installed, the annulus of the adit is bricked up to stop any overflow surcharge in the manhole from backing up into the chalk adit. Using this technique means that the risk of exfiltration is removed. Next slide.
So when we first presented this project to the Pipeline Industries Guild, it was November 2019. We were in full flow, working on site, and we were about 3/4 of the way through the project at the time. Now I'm happy to say we are 100% complete. We ended up finishing just at the end of May rather than March, for reasons we'll come on to in a little while. Next slide. So over the 18 months we were on site, we worked over 310,000 safe man working hours. We ended up sending out 32,000 letters to local residents to keep them informed. Yeah, and we installed the 7 kilometers of adit liner. I did the adit prep and roughly ended up relining over 4.6 kilometers of new sewer, which we weren't, of existing sewer, which we weren't expecting to at the start of the project. Next slide. Okay, so on such a large scheme with such a high-risk nature, we needed to ensure that health and safety was our utmost priority. With an 80-strong workforce working up to 28 metres deep, with multiple vertical and horizontal crossings, health and safety management was a critical part of this scheme. Having worked on the first phase of this project and having a greater understanding of the risks, we were able to put together a comprehensive safe system of work and RAM system that was above industry standard, whilst keeping things efficient and simple for the workforce. An example of this is the tally board shown on the right. This simple tool not only shows the workforce, but any visitors, who is working underground, who is the top man in control of the confined space, what the emergency contact numbers are, and who the first aider for the site is. The tally board also shows the street that the team are working on, where exactly in the adit that they are working. So in the event that a visitor needed to raise the alarm in an emergency, they could do so without having to know the specifics of the work. Next slide. As Mark mentioned, with over 310,000 safe man hours worked, we are proud of a health and safety record with 0 major accidents, 0 lost time incidents, and only 26 minor incidents. Majority of these incidents were small service strikes on uncharted water services that were being excavated by hand. We're also proud to have 141 near miss or improvement suggestions, which were encouraged throughout the scheme, and 20 of these 141 were good observation practices. We put a system in place to encourage the reporting of near misses and improvement suggestions via the use of improvement suggestion cards. These are available in all of the site canteens and in the main site compound, and were encouraged by the site management as a way of highlighting ways for all of us to improve while carrying out the works. We even had a reward scheme with an M&S voucher for the best improvement suggestion each month, which was well received on site. Both the client and the contractor senior management teams carried out combined and individual health and safety audits, and feedback suggestions were passed down through the work teams. For us as a project team, the Environment Agency were our key stakeholder in this project. And we were really lucky in a way, because the head of groundwater for the Environment Agency is based in Kent, and this project is one of her hot topics and something she's really passionate about. So it was great for us to be able to get the EA involved and make them part of the collaborative team. To the extent the EA come and did toolbox talks on our induction days. They come to site quite often, and Jan Hookie, her name is, was part of the project team, and we took her along the journey with us as we went.
Okay, so innovation. Innovation was not only a key part of the tender process, but also the construction phase. Through the use of trenchless technology, man-entry techniques, which require a small site area, we were able to reduce disruption to the local community, businesses and schools, whilst also reducing our carbon footprint and limiting the environmental impact. Great care was taken to develop techniques that would avoid the use of any materials that may have had a detrimental impact on the aquifer or the wider environment itself. Through collaboration with the EA, it was agreed that the use of a UV-cured CIPP liner, as opposed to a more traditionally cured liner, would remove the requirement of using chemicals and resins in the curing process. Next slide.
For us as a project team, this was a major comms piece. When you think we could be working in a residential street for up to 3 months at a time, and at the end of that period of time, all the customers would see would be a new shiny manhole cover. So for us, educating everyone as to what exactly we were doing and bringing our customers along the journey with us was vitally important. At any one time, we had 15 teams working on site, and it's a densely populated area, so we were having a major impact on the local area. And as a project team, we also had to have a close working relationship with KCC Highways because we worked in 170 streets. There were 18 key schools in the area, and our program had to fit in with the school summer holidays. It's a seaside town, and we did everything we possibly could in order to have as minimal impact on the local community as possible. Next slide. Sorry, someone's drawing. This is what we had a dedicated comms team for this project, and this graph just shows roughly how many letters we were sending out to the local community per month as we move forward, and we were monitoring unwanted and wanted contacts so that we could develop our comms strategy as we went along. As I said earlier, with 32,000 letters sent, our unwanted contacts run at roughly 0.7%, which against our stretch target of 2% is pretty good. Next slide. Following work in each street, we would go around and do a feedback questionnaire with the local residents, knocking on their doors, and any feedback we were getting, we would tweak how we were working in streets moving forward, again to minimise the disruption as much as possible. Next slide. And we as a project team, we were looking right at the minute detail, so we could tell you how many letters were sent out to each street versus contacts, what the problems were in specific areas, and we were able to tweak what we were doing in order to change road by road as we went. Next slide.
Okay, so as Mark mentioned, community and stakeholders was a vital part of the scheme for us. We purchased a customer bus, which we set up in key areas where we were going to be working for a long period of time. We decorated it with key site messages, photos of the works, along with key water for life messages from Southern Water. We placed Southern Water signage and imagery on all of our sites to show that we are proud to work with Southern Water and give the impression that we cared about the work we're doing and the area that we're working in. We carried out joint presentations, one in a local hotel nearby to where the works were being carried out. We invited local councillors, members of the public, local residents to see in detail the works that we've been carrying out. We even brought a life-size timber heading and section of CIPP liner, as you can see in the bottom right photo. We also brought along some confined space equipment that we used to enter these tunnels to show the sort of conditions that we were working in. We also trained all of our workforce to have customer-facing training from an external company called Dramana. This was an invaluable experience and gave the workforce a different perspective of the impact of their works on the residents. This enabled them to keep disruption to a minimum and talk to the residents confidently about the works we were carrying out. Next slide. Another thing that we were really passionate about was giving back to the local community whilst we were working in the area. We carried out beach cleans on Saturday mornings to help clean out the local beaches. This was a great thing to do and something that the workforce were also engaged in. We ensured local businesses remained open and access was granted to these businesses, letting the public know at all times how to access these areas. We even managed to do our bit for the local environment by saving Henry the hedgehog, shown in the top left photo. Henry was found at the top of an excavation at the start of works one morning, and we rescued him to a local veterinary centre and managed to rehome him. One of our proudest moments, however, was helping the youth today and working with the local school as part of the engineering education scheme. This was a scheme where we spent time with a group of sixth form students who had an interest in engineering and gave them a brief design to complete a project similar to Thanet sewers. We worked on topics such as engineering design, logistics, customers, public relation, cost and legacy issues. The students had to project manage themselves and present a solution to a board of industry experts. The students that we worked with worked really well and they managed to win the award. They were extremely happy and grateful for the time we spent with them, as you can see from their smiling faces and the trophy on the right hand side. Next slide. This slide is just showing a few examples of the customer satisfaction that we receive while working on the scheme. We received numerous cups of tea, cakes, chocolates, biscuits and sweets from residents around the works where we carried out. The workforce were extremely proud of this and they strived every day to make an impact on local residents and showed they care about the area, not just the works that we were carrying out. It was something that we were all really proud of as a project team. Next slide.
So as I said at the beginning of the presentation, the reg output date for this project was the 31st of March 2020, and we only completed at the end of May, largely due to obviously COVID and the current situation that we've got going on. As you can imagine, confined space working and working in underground tunnels when you're being advised to socially distance isn't the easiest thing to do. So immediately when it was announced, we had to have a stand down and we had to revise all of our health and safety systems, our RAMs and our safe working practices, hygiene practices, anything in order to abide with government legislation, or government guidance at the time, sorry. We had to carry out live trials of working socially distanced to check that we could carry on and do the work that we were trying to do. We ended up having daily conference calls between TPMD, management and Southern Water to understand and work out how we could deliver our work carrying on. We went from 15 teams to 3 teams on site virtually overnight, where staff returned home because they had vulnerable people, etc. And a lot of our local suppliers where we were getting materials from started shutting down. So it ended with a 2-month delay to the programme, but we were able to complete, and the best thing about it was we had absolutely no positive COVID-19 cases at all within our workforce. So that's about it from me and Keiron. So if there's any questions, feel free to unmute yourself and ask away.
Thank you.
Keiron, that's really, really interesting talk. Thank you very much. Just to let people know, if you want to ask a question, just type it away in the chat box on the right hand side and we'll try and address them one at a time. I must admit, I've worked on an awful lot of historic pipelines. I haven't done anything on tunnels like that. It's quite unique. We're all very quiet on the chat window. Just type away if you see any, if you think of anything.
Yes, it's the only area in the UK with a sewer network like it, so it is very unique.
Go on, say, I think we've got about 25 people on the call. I can't believe there's no questions coming in.
You must have answered all of them.
Anybody want to ask anything out loud? If that's any easier, we're having troubles with the chat window. Nope, I think you've stumped everybody, answered everything in the presentation.
There's a question that's just come in. Do you want to answer this one, Keiron?
What software did you use to capture the asset details during the investigation, i.e. from manual inspections?
Okay. In terms of software, it was very basic from the outset. So it was manhole surveys carried out by hand, put into the software that Southern Water were using as part of their hydraulic model. We would have information such as size, damage, making sure that we understood the exact depths of the manholes, the size of the manholes, to make sure they matched up with Southern Water's records. We also then took a series of stills and video footage so that the hydraulic modelers understood exactly what we were working with and not just seeing analytical data. So we made sure it was really practical, so they really understood, and that worked really well to enable all of us to understand. As you said, this is quite unique, and the model had to reflect that. It couldn't just be an analytical piece.
Thanks, James, for that first question. Harry, Catrall's asked, how did you ensure that the lining was watertight?
So in terms of the lining, the structure itself is a CIPP structure which becomes harder with curing. The water tightness of the structure, it's a complete one piece, which is tested and checked at the end of it. And then the watertight section comes from inside the manhole. So we designed a system where at the end of the manholes, we seal them using hydrophilic strips, manhole ties, brickwork, etc., which was shown in one of the slides earlier, to make sure that any surcharge flows that came up in the manhole would only go back down through the liner and not back into the chalk adit itself.
Thank you. From Sandra, was I correct in understanding the sewer was concreted into the floor of the audit and then the cured in place liner used to line the adit, and was that to accommodate storm flows in the adit?
Okay, so yes, the existing sewer that was in place was left free in place before we started the work, so there was lots of opportunities for it to be damaged, whether it was chalk falling from the roof, whether it was from people entering the tunnels and standing on and breaking the pipework. So the existing sewer was rehabilitated by the work. We then put a protective cover slab over it, which was the concrete floor, and then that was again used as a base for the CIPP. CIPP liner then, as you say, accommodated any storm flows over and above the flows that would be kept in the sewer itself.
Great. All from Chris. If you could start again, what changes or improvements would you make? How your lessons learned?
I think for me, getting the survey work, specifically walking the adits as soon as possible into your design is quite critical. There is a balance though. We did it about halfway through the process, and there were changes, as in further collapses, etc., between doing that survey work and when we come back to actually do the physical work later on. So the earlier you do that, the more chance there is for those changes to happen, but you're minimising kind of project scope and creep really. So getting it done as early as possible would be my recommendation moving forward.
One from John Cole. You indicated that you were able to fill the roof voids without digging out the road. Could you elaborate on the method used?
Okay, yeah, John. What we were able to do in certain cases, depending on the depth of the void above, was to create a shield inside the adit by using the timber heading method, and then pack the void internally with dry mixed concrete. So depending on the size and scale of the concrete, the dry mixed concrete would again be brought down the manhole in a chute, be transferred to the location in a skip, and then we could physically put that concrete into the void, pack it into place with a small bespoke made packer, and fill the void that way. Then what we would do is drill down on the surface of the road, install a camera, check that we had got all of the, a small flexible camera, ensure that we had created all the voids to be concreted and solidified, making sure that we didn't have to completely excavate the road above, shut the road. So it was a technique that worked in the majority of cases where we found voids, and saved a lot of issues with permitting of the road by KCC.
Right. From Mike, what is the lifespan of the Lightning?
One for you, Mark.
I'd have to take that one away and have a look.
Yeah.
I know I've got it somewhere, but I can't remember off the top of my head.
You'll have to say who the supplier was?
Yeah, the supplier was Reline Europe. So it's a pretty, I can't think whether it's 100 or 120 years, I'm not sure. But it's it's a solid product that comes with all the specifications and life guarantees.
Great. And last question from Rachel: was there any consideration for future catchment growth of flow increases?
Yeah, so during the modelling process, there were lots of different models that were ran. We allowed for 1 in 20-year floods, 1 in 30-year floods, with climate change, without climate change. We also took into consideration, obviously we're working on a scope of works, but when we got to a certain manhole and found problems ahead of us that weren't part of our scope, we would still look at them and consider if they would cause detriment in the near future. That's why the scope is always evolving, because you're continually finding things along the way that weren't part of the original scope. So then we had to make sure that we could cover that and make sure that we were creating a project that was suitable for the future as well.
That's great. Keiron, really appreciate the talk today. Thank you very much. Very unusual. We've got these talks going on most weeks now. Next week we've got planned in, I think it's Wes Little from Control Point talking about artificial intelligence in PE jointing. And we've got 1 or 2 others that we're trying to line up in the future that we'll have very quickly on the big website. This talk will be put on the YouTube channel in the next day or 2, which gives us a couple of days to just work on the download it and get it uploaded, but it should be there hopefully by next week. Thanks for all your time today, everyone. Cheers. Goodbye.
Thank you.
Thank you, everyone.
Thanks a lot.